Good day, everyone. I am Christian L. Salazar, a secondary school mathematics teacher at Tandag National Science High School, City of Tandag, Philippines. This day, allow me to present to you my research entitled Influence of Productive Struggle in Mathematics to the 21st Century Learners. Perseverance is a fundamental component in problem solving on the grounds that the first or second approach or strategy may not bring about in a reasonable solution. When students get engaged in a task, they should be mindful about the strategy they use and evaluate whether it is productive or not. When they find that they are at an impasse, they should be willing to surrender one strategy for another. When students make an effort and struggle but continue to pursue to try to comprehend a problem, they are engaging in a productive struggle. This study is all about productive struggle, wherein it is developing strong propensities for mind, such as perseverance and thinking flexibly, simply seeking the correct solution. As stated by Kang in 2007, productive struggle requires that teachers will provide non-routine problems that cannot be solved with a formula, and this is supported by Waller in 2014. For him, it is a method of bringing students outside their comfort. Problems that support productive struggle allow room for exploration and inquiry rather than rote exercises that require application of already known procedures. These exercises tend to foster practice of skills and encourage the use of particular algorithm. Encouraging students to make sense of the problem, understand it, and devise plans for how to solve it mathematically is the key in establishing an environment that supports productive struggle. More recently, Hebert and Wern in 2007 stated all students have to undergo struggle with brain-stimulating problems if they want to learn mathematics deeply. Although the circumstance that we call a struggle may be internal, it can also be experiential in most classrooms. In the context of classroom interactions, students may voice disarray over directions, the wording of a problem, the inquiry being posed, or how to develop a strategy. Students may voice a remark of, for instance, "I don't get it." A teacher may identify students' misguided judgments that yield contending claims, uncertainty, and intellectual clash in the student's thinking. An error while solving a problem may lead to a nonsensical answer that astounds a student. A student may be very engaged in working in a mathematics problem, but when arrive at an impasse and get stuck. These things were observed in the graded students of the Tandag National Science High School, in which the researcher believed that to be one of the reasons of the low quarterly mean percentage score, where in fact they got 63.20% in the third periodical examination, which is far from the 75% target of 2019 to 2020 annual school improvement plan. Therefore, it is crucial to immediately find a proof and solution to this knowledge gap. Having deemed of this necessity, the researcher finds the need to pursue this study. This study aimed to find the influence of productive struggle in mathematics to the 21st century learners. In particular, it seeks to find answers to the following questions. 1. What is the mean score of the learners with or without using activities that promotes productive struggle? 2. What is the level of influence of using activities that promotes productive struggle in Mathematics 8? 3. What problems were encountered in the use of activities that promotes productive struggle in Mathematics 8? 4. Is there a difference in the achievement test scores of the students with and without activities that promote productive struggle? 5. Is there a significant interaction in the achievement test scores of the students and their mental capacity? 6. What intervention program can be proposed as an output of the study? This study is also guided by the following hypothesis. Hypothesis 1. There is no significant difference on the achievement test scores of the students with and without the activities that promotes productive struggle. Hypothesis 2. There is no significant interaction on the achievement test scores of the students and their mental capacity. In this study, the researcher utilized the quasi-experimental pre-test post-test design to determine the influence of productive struggle to the 21st century learners. In this design, two groups of students were involved, the experimental group and the control group. Two intact classes were utilized in this study. A pre-test post-test design is an experiment where measurements are taken both before and after treatment. The design was utilized in this study so that the researcher will be able to see the effects of the treatment on the experimental group. The study took place at the Tandag National Science High School. It is a high school system of secondary public sciences in the city of Tandag in Surigao del Sur, Caraga region, which caters grades 7 to 12 students. The subjects of this study were the grade 8 students who are currently enrolled at Tandag National Science High School for the school year 2019 to 2020. There are two sections, grade 8 Alien and grade 8 Euclid, and there are approximately 23 students in each class. One section was randomly assigned as the experimental group and the other section was the control group. Out of this number, only 44 was considered as the subjects of the study because the maximum number of students in one of the sections is 22. The 22 subjects in each group were chosen according to their general average in mathematics subject from first quarter to third quarter of the same school year to ensure that the two groups are comparable. The table showed that mean scores of the pre-test and post-test of the two controlled and experimental group. Each group has been subdivided into two different groups which was based on their mental capacity, the high grades and the low grades. Based on the table presented, we can see that the difference of the pre-test mean scores of the control group, high grades of 21, and experimental group high grades of 24.64 has only a difference of 0.36, while the control group low grades with a mean score of 16.09 and experimental group low grades with a mean score of 16.64 has a difference of 0.55. This denotes that during the conduct of the study, the subjects are of equal knowledge when it comes to the topics in the fourth quarter. Pre-test is conducted before the actual discussion of the topic to measure the level of learning that the subjects have in their past experience. Furthermore, the table showed that post-test mean score. It is very evident that the experimental group has a higher mean score for high grades 41.73 and low grades 37.82 compared to the mean score of the controlled group for high grades 37.82 and low grades 22.64. This implies that the use of activities that promotes productive struggle is more effective than that of traditional way of teaching mathematics. On the basis of the result of the study, the use of activities that promotes productive struggle engages students in active learning, develops self-esteem, and promotes academic achievement. Concepts learned independently are easy to be remembered. The result further implied that students with high and low mathematical ability will achieve better through independent learning in teaching mathematics compared to the high and low levels of mathematics ability in which the teacher alone teaches through a lecture method of teaching. The table showed that the use of activities that promotes productive struggle in teaching mathematics is extremely influential with a weighted mean of 4.38. Moreover, the indicator 10, which states that productive struggle helps the subjects to be motivated, managing, and trying to improve their skills in mathematics problem solving, ranked first and got a mean score of 4.73, which is extremely influential. On the other hand, indicator which states that productive struggle exposes and discusses common misconceptions ranked last with a mean score of 4.00, which is very influential. It can be gleaned from the table that problems encountered in the use of productive struggle get a weighted mean of 3.46, which is a more serious problem. The problem that majority of the students encountered was being unable to finish the activity in a given amount of time. They often struggle with the idea that they are given a problem or activity to be solved without a preview of the lesson. Thus, they resorted to trial and error method of getting in answers and oftentimes undergone series of steps in arriving to an answer in which they are not sure about. Based on the table presented, at 0.05 significance level, it showed that pre-test has a p-value of 0.939, which is greater than 0.05. Thus, we failed to reject the null hypothesis. Therefore, it can be concluded that there is no significant difference with the pre-test scores of the students in the controlled and experimental group. It can then be deduced that the scores are closely related to each other and thus giving an insight that during the conduct of the pre-test, the subjects have equal knowledge on the lessons of the fourth quarter. On the other hand, the table above showed that 0.05 significance level post-test has a p-value of 0.000, which is less than 0.05. Thus, we have to reject the null hypothesis. Therefore, it can be concluded that there is a significant difference with the post-test scores of the subjects in the controlled and experimental group. This only means that the scores in the experimental group are higher compared to the scores in controlled group. It only shows that activities which promotes productive struggle is effective in increasing the scores of the students where they have almost the same level in understanding the concepts well. and that resulted to their high scores in tests. The table underscored the findings on the significant interaction of the achievement test scores of the students when they are grouped according to their mental capacity. It can be gleaned on the table. At 0.05 significance level, it showed that control group, both high grades and low grades, has a p-value of 0.299 and 0.201 respectively, which is greater than 0.05. Thus, we fail to reject the null hypothesis. Therefore, it can be concluded that there is no significant interaction within the controlled group if they will be sorted as their mental capacity. It can then be inferred that regardless of the mental capacity of the students, all the subjects have almost the same level of difficulty in answering the problem, that they have almost the same level of knowledge as to the lessons in the fourth quarter when they are exposed to the conventional method of teaching. After the experimental group has been subjected to the different methods, post-test has been given to both groups to measure how much they have learned during the conduct of the study. It is evident in the table that experimental group for both high grades and low grades has p-value of 0.00 and 0.002 respectively, which is less than 0.05. Thus, we must reject the null hypothesis. Therefore, it can be concluded that there is a significant interaction with the achievement test scores of the subjects in the experimental group if they will be sorted as to their mental capacity. The results only suggested that those subjects which are exposed to activities that promotes productive struggle performs better than those who are exposed to conventional method of teaching, even if they are grouped according to their mental capacity. Based on the findings of the study, the following conclusions were drawn. In view of the mean scores of the subjects in pre-test, it can be concluded that during the conduct of the study, the subjects have equal knowledge and understanding when it comes to the lessons in the fourth quarter. On the other hand, there is a huge difference between the mean score of the experimental and control group. It can then be deduced that activities that promotes productive struggle is more effective as compared to the conventional way of teaching. The researcher concluded that students are more likely to be internally motivated to engage in productive struggle to achieve a goal. Furthermore, a productive struggle makes the subjects eager for new challenges and enthusiastic rather than fearful about learning from mistakes. It can be concluded that when students are engaged in a productive struggle, they have to be given enough time to answer the problem or to finish the given activity. Since there is a significant difference between the achievement post-test scores of the experimental and controlled groups, it can then be concluded that activities that promotes productive struggle has engaged the subjects in active learning. It has developed self-esteem and promotes academic achievement. Concepts learned independently are easy to be remembered. It can be concluded that when activities that promotes productive struggle will be incorporated in teaching mathematics, the students with high and low mathematical ability levels will be improved more in the mathematics achievement compared to the high and low mathematical ability levels were taught solely by the teacher through lecture method. Based on the findings and conclusions presented, the following recommendations are suggested. The researcher recommends that school administrators and mathematics teachers shall utilize activities that promotes productive struggle as one of the means of independent learning to increase the achievement test scores of the learners. In attaining quality education, the use of productive struggle in teaching mathematics is recommended to be employed quarterly. After implementation, evaluation shall follow. It is to ensure that students achieve high academic performance through tracing the development in their scores every grading period. The teachers and administrators should have orientation with regards to independent learning under the K-12 curriculum. Trainings and seminars are suggested to train them and be able to apply the strategy efficiently. Educators are recommended to have a seminar on localizing and contextualizing of instructional materials. This will help improve the content of the activities. Using examples that are found in the community will help the students understand the topics. Teachers are recommended to incorporate productive in teaching. Every topic shall have corresponding activities. Activities that will be used by the learners shall go through careful editing to ensure that everything is well polished. It is recommended to have experts check every component of the activity to ensure that it meets the necessary standards and features for effective lesson outcomes. That will be all for my presentation. Thank you so much for listening.